Final exam for science. Part 1. Scientists have used information on hundreds of eruptions to create a map of active volcanoes and tectonic plates. See Figure 1 below. Scientists are interested in understanding volcanic activity, particularly in the Ring of Fire, and wonder if they can use this map of the Ring of Fire to help predict when and where there may be future volcanic activity. Number 1, Part 1A. What is the pattern of active volcanoes seen on the map? Figure 1. Choose one answer below. Most active volcanoes occur along tectonic plate boundaries. Most active volcanoes occur in the middle of tectonic plates, away from the plate boundaries. Active volcanoes are randomly scattered throughout the area shown in Figure 1. Number 2, Part 1B. The map, Figure 1, was made in 1997. What do you predict will happen to the pattern of active volcanoes forming the Ring of Fire after 100 years in 2097? Choose one answer below. The Ring of Fire will no longer exist. The number of active volcanoes and the location of active volcanoes in the Ring of Fire will remain exactly the same. The pattern of volcanoes forming the Ring of Fire will be the same, but the exact number and locations of active volcanoes will change. Number 3, Part 1C. Use your understanding of plate tectonics to describe why you chose your answer for Part 1B. I chose that answer because tectonic plates move really slow, but volcano frequency changes often. I chose my answer because the Pacific Ocean will be gone in 100 years. Number 4, Part 1D. Some volcanoes that make up the Ring of Fire have produced large eruptions, but other volcanoes have produced only small or medium eruptions. The number of eruptions by a volcano over a period of time can be used to calculate the volcano's frequency of eruption, which is useful for predicting future eruptions. For example, a volcano with frequency of eruption of 25 would erupt on average once every 25 years. In the graphs below, each plotted point represents the size and frequency characteristics of a single volcano. The statement beneath describes the pattern shown in the graph. Select the graph plus statement below, which indicates the relationship between eruption size and frequency of eruption of Earth's volcanoes. Choose one answer below. A. The largest eruptions occur with the highest frequency. The smallest eruptions occur with the lowest frequency. C. The largest eruptions occur with the lowest frequency and the smallest eruptions occur with the highest frequency. D. All sizes of volcanic eruptions occur with the same frequency. Part 2. Scientists have noticed that oceans between two continents can change in size over time and wonder how that can occur. One theory using plate tectonics is described in the models below. Figure 2 shows a side view or cross-section of the past 100 million years, arrangement of two continental plates, X and Y, and an ocean plate. Figure 3 shows a side view, a cross-section of the present arrangement of the same two continental plates, X and Y, and the ocean plate. Tectonic plate positions 100 million years ago. So look at the pictures. Number 5, Part 2A. In present day, Figure 3, where is ocean plate being created? Choose one answer. In the middle of the ocean plate B, near the divergent boundary within the ocean plate C, or where the ocean plate is underneath the continental plate X, D. Number 6, Part 2B. In present day, Figure 3, where is ocean plate being destroyed? Choose one answer. At the boundary of the continental plate X and ocean plate A, near the divergent boundary observed within the ocean plate C, where the ocean plate is underneath continental plate X, D. Number 7, Part 2C. Which way should the arrows be pointing at point E and point F above? Mark only one oval. Number 8, Part 2D. What evidence can you use from Figure 2 and Figure 3 to show that the continents have moved? In Figure 3, the X and Y plates are closer together. In Figure 3, there is more ocean plate between the X and Y plates. Number 9, Part 2E. Scientists have discovered that the rocks that make up the ocean plate have different ages. Younger rocks compose some portions of the ocean plate, while older rocks compose other portions of the ocean plate. Use Figure 2 and Figure 3 to describe where you would expect to find the youngest rocks in the ocean plate. Point B, point C, or point D. Geologists have observed an interesting phenomenon in this region of Idaho and Wyoming. There is a set of calderas that form a linear pattern. See Figure 4 to the right. Geologists have been able to establish ages for each caldera, labeled on the figure. The volcanic rock samples taken from the calderas have the same composition, so geologists know the calderas were formed from volcanic activity by the same hotspot. Teacher note, for simplicity, age values are rounded. The youngest values from multiple caldera forming events were used for the Heiss caldera and Yellowstone caldera. Hotspot calderas, Figure 4. Part 3A, which caldera is the oldest? Yellowstone, Peekaboo, McDermott. Number 11, Part 3B. Assume that the hot spot which caused the volcanic activity that produced the calderas is fixed in position under the continent. What do the ages and locations of the calderas tell you about movement of the North American continent? Choose one answer below. The continent has moved in the same direction over the past 15 million years. The continent has moved back and forth in opposite directions over the past 15 million years. There's no evidence to show that the continent has moved over the past 15 million years. Part 4. Geologists developed a partial model to help understand how Cotopaxi, an active stratovolcano in Ecuador, was formed. Cotopaxi volcano is in the Andes mountain range of South America. The partial model below, Figure 5, shows a side view or cross-section of the stratovolcano, which is located where the ocean plate meets the continental plate. The model is not to scale. It is meant to highlight the volcano structure and its magma chamber underneath. The dashed lines represent the approximate shape of the ocean plate. Model of Ecuador, Figure 5. Look at that figure. Number 12, Part 4A. Does the picture below best show where crystallization, C, is happening, where melting, M, is happening, and where flow of energy is happening, the arrow? Yes, because melting occurs where the two plates meet the crystallization, where meet and crystallization occurs, where the magma comes out and cools. No, because the melting would occur closer to the surface of the volcano, and the crystallization occurs only in the ocean. Number 13. How do the gray rocks from the stratovolcano form? Continental plate rocks are melted by the mantle and flow upward. Both ocean plate and continental plate rocks are melted by the mantle and flow upward. Number 14, Part 4C. The Andes mountain range, where Cotopaxi volcano is located, is the longest continental mountain range on Earth. The mountain range stretches over 4,000 miles along the western edge of the South American continent, where it meets the Pacific Ocean. See the light gray area of Figure 6 to the right. The mountain range is made up of many active and inactive stratovolcanoes. Geologists collected a set of rock samples from 4 additional stratovolcanoes within the Andes mountain range, shown by the white X's in Figure 6. They found that the rocks from these volcanoes all have a similar gray color and composition, as the rocks from Cotopaxi. After studying the set of rock samples, geologists made the following claim. The entire Andes mountain range was formed by the same tectonic process that formed Cotopaxi volcano. Select 3 pieces of evidence from the statements below to support the geologist's claim. So there's 4 options. You're going to choose 3. The volcanic rocks have the same color and composition throughout the mountain range as Cotopaxi. The material, or lava, that is erupted from volcanoes comes from the magma chamber under the volcano, so the rocks can be used to show what materials have formed the magma. The model shows Cotopaxi volcano forms where the ocean and continental plates meet. The entire Andes mountain range is located along the same type of boundary, convergent, where the rocks are brown and look like rocks from the North American plate. Number 18. Number 15, Part 4D. Which is the best reason of why Cotopaxi and the Andes Mountains are formed by the same process? Choose 1. Cotopaxi is made from light rock and Andes are dark rock. The tectonic process that formed Cotopaxi volcano is the same process that formed the Andes mountain range because the process of melting, crystallization, and movement of matter where ocean and continental plates converge is the same for both. Both are tectonic processes of divergent plates. Number 16. What is the difference between magma and lava? Magma is melted rock that has erupted onto the surface. Lava is inside the earth. Magma is the melted rock in Earth's interior. Lava is the melted rock that has erupted onto Earth's surface. Number 17. Which of the following vocabulary words matches this definition? A divergent boundary within an ocean plate where new seafloor is created, marked by a disruption of Earth's surface into a mountain range with a high thermal energy flow and volcanic and earthquake activity. An example is the Mid-Atlantic Range. Is that convergent boundary, mid-ocean ridge, or lava? Number 18. Which of the following vocabulary words matches this definition? To change a liquid material into a solid by removing or releasing thermal energy. Is that subduction, flow of energy, or crystallization? Number 19. Which of the following vocabulary words matches this definition? An indicator used to describe and compare eruption size based on the volume of material erupted by a volcano. Magnitude, tephra, eruption frequency. Number 20. This volcano is formed by a mantle plume under a continental plate. Which volcano is it? Kilauea, Yellowstone, Hecla. Number 21. This volcano has light-colored rock because the flow of energy melts a continental plate, the flow of energy goes through a divergent boundary, or the flow of energy goes through a convergent boundary. Number 22. In this Kilauea model, the black dots or pieces represent what volcanic process? Melting, crystallization, flow of energy. Number 23. Kilauea's flow of energy causes what process around the magma chamber, represented by the yellow dots? Crystallization, melting, convergent boundary. Number 24. This volcano is formed by 2 continental plates moving apart. Which volcano is it? Kilauea, Mount St. Helens, Hecla. Number 25. This volcano has dark basalt rocks causing the cycling of matter because the cycling of matter is going through a subduction zone, continental plate, ocean plate. Number 26. Mount St. Helens is formed by which volcanic process? divergent plates, convergent plates, mantle plume. Number 27. What is moving under Mount St. Helens to cause the volcano? Continental plate, crystallization, ocean plate. Number 28. I am a steep-sided, often cone-shaped volcanic peak formed by layers of ash, relatively sticky lava, and other eruption products. Which volcano am I? Stratovolcano or fissure vent? Number 29. I am a broad, dome-shaped volcano with gently sloping sides formed by layers of relatively fluid lava. Which volcano am I? Shield volcano, fissure vent. Number 30. I am a linear volcanic vent or vents through which lava and gases erupt, usually without any explosive activity. It may consist of a single long vent or a series of vents oriented along the same linear direction. Which volcano am I? Stratovolcano or fissure vent? Number 31. Small solid particles that are emitted from a volcano during an eruption into the atmosphere. Is that volcanic ash, magnitude, or stratovolcano? Number 32. A major area on the edges of the Pacific Ocean basin where many earthquakes and volcanoes occur. Crystallization, andesite, the Ring of Fire. Number 33. Thin crust beneath Earth's big oceans. Pacific Ocean, Atlantic Ocean. Is that plate motion, ocean basin, or tephra? Number 34. The emission of volcanic products such as lava, ash, and gases from a volcano as a geologic process. Volcano eruptions usually occur as sudden events. Is that plate motion, ocean basin, or eruption?